Welcome to 6.1 Law of Sines. This should not be our first view of this if we're in trig pre-calc. They do give us our law of sines formulas, which should be somewhat familiar with. I do want to emphasize that I don't always treat it as side over angle, side over sine of angle, side over sine of angle. I might deal with it as sine of A on side A equals sine of B on side B equals sine of C on side C. The reason I switch those around, and of course we can do that mathematically, is I always want my unknown here. That makes, so if I've got A, B, C, I understand these are not sides, these are just values in a proportion. Easy to solve for x, all I have to do is take A and multiply it across. So x equals A times B divided by C, and I can go to calculator that way. So I always put the unknown in that position. Okay. Oblique triangles are triangles that do not have right angles. Some are acute, and some are referred to obtuse when they have an obtuse angle. And things to be alert with using law of sines are when we're given a side-side angle problem. See, if we go back to geometry, to when we prove triangles congruent. Triangles congruent. We would use side, 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 angle, side, angle, side, angle, 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 side, but we could not use side, side, angle, or worse yet, angle, side, side. We couldn't use those because it doesn't guarantee congruence. Let's think about law of sines for a moment. If we're going to use law of sines, angle A, angle B, angle C, side A, side B, side little c. We need to know three pieces in order to find a fourth piece. But so let's say we're working with this. I have to either know two of these or two of these. I have to know two of these and one of those, or both of these and one of those. So I always have to know a side and an angle opposite it. For instance, if I had, let's say this side length was 6, this side length was 7, and this was 53 degrees, I can't use law of sines. Because what am I going to do? Say sine of this angle over this equals sine of this angle over that. I'd have two unknowns no matter how I do it. So if I have side, 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 let's say this is 5, 6, and 7. I can't use law of sines because I would always be missing two angles in my proportion. So I can't use it here, I can't use it there. I understand if I know two angles, I really know all three, so we can use both of these. But we can also use side-side angle even though it doesn't guarantee congruence. Let's say this is 7 and this is 6, and this angle is 28 degrees here. Not very accurate, but now I could say that, okay, sine of this angle on 7 equals sine of 28 degrees on 6. The problem with that is sometimes we get two solutions, and it's possible to get no solutions. I'm going to talk more about that when we get to an example like that. And then we've got some area formulas, which are kind of nice. The area of a triangle, that what we're used to is area equals 1/2 times base times height. So that's when we have a right triangle and the height is through here. But now we don't have a right triangle. Oops, that wasn't even a right triangle to begin with. But that's when we have a right triangle, sorry, and the base and the height is actually one of the sides for a right triangle. Okay, or the height is through here and then we have to calculate it. But this just allows us to use two sides if we know an angle. So let's take a look. If I have angle B, A, angle B, sorry, and C. Let's see, 1/2 BC. So this would be like I know angle A, 62 degrees. I know side B, and I know side C. I know side B, and I know side C. Oh, okay, 7 and 8. That's when we have side angle side. This is a side angle side formula. But it's like 1/2 base times height. It's just the height isn't one of the sides. And it's a pretty easy proof to show you that sine of A adjusts for one of the sides not being the actual height. So like you take C times sine of A and you actually get the height away from B, side B, or vice versa, however you want to look at that. Okay, so let's take a look at some examples here. Solve the triangles. So here we've got a triangle, we've got some given parts. I would do this way. I'd say we've got angle A, angle B, angle C, side A, side B, side C, and we know angle A is 20 and we know angle B is 30 degrees, and we know side C is 30 feet. If I know two angles, we certainly know the other. 180 minus 30 minus 20, or 180 minus 50, is 130 degrees. And now we can find side A or side B. Since I'm looking for side A, I'm going to say A on sine of A, sine of 20 degrees, equals 30 on sine of 130 degrees. So this makes it really, really easy to go to calculator without even showing this step. All I have to do is multiply sine 20 across. So I get sine of 20 degrees times 30 divided by 130. So we'll pull up our calculator. Make sure we're in degrees, mode degrees. We've been working in radians for quite a while. Sine 20, close it, times 30. Whoops. This should be, in the denominator, should be sine of 130. Sorry, you probably noticed that. Divided by sine of 130. Enter, and I get 13, and we're going to round to tenths here, 13.4. So side A is about 13.4, but not exactly. To find B, we're going to go B on sine of 30 degrees equals, now I, in theory, have my choice. I could go 13.4 on 20 or 30 on 130, but there's a couple reasons I want to go 30 on sine 130. And the most important reason for doing that is 13.4 is a little bit of an error. And we may end up compounding errors and get bigger rounding errors as we do that. So we use the exact values. Another good reason is as I'm doing this, if I go second enter on my calculator, I can just edit this, and what has to really change here? Well, I need to multiply by sine of 30. Multiply sine 30 across to 30 and divide by 130. And I get 19.6. And now I'm going to show you something. Not everybody does it. I grade tests. I talk about it all the time. There's two quick tests you can make to check these. Well, obviously, we can make sure all our angles add up to 180. But two quick tests. One is, here's our biggest side, 30. It's opposite our biggest angle. And here's our smallest side, 13.4. It's opposite 20. That's one of the tests. And, of course, middle side, middle angle. The second test is to find the sum of your two shortest sides, over 13, over 19. If I add those together, I'm over 30. The sum of the two smaller has to be greater than the longest side. That's a geometry property that should make some sense to you. Okay, let's take a look at 14. And let's draw this guy. I'm not going to try to draw this to scale. You may if you want. A, B, C, side. So let's fill in what we know. Side A is 34. Side B is 21. Angle A is 76 degrees. And, we have an issue here. We have a side angle side, or excuse me, we have an angle side side or a side side angle problem here. And that presents us some challenges to us because side side angle does not guarantee congruence. I can law of sines and find angle B. So I want to show you why this is a problem. Let's say, for instance, that I'm told that we have an angle let's say we have an angle of 30 degrees, and let's say this is a side-side angle problem. We have an angle of 30 degrees that's adjacent to a side of length 9 that's adjacent to a side of length 7. So I'm going to just sketch out, here's our 30-degree angle, and I'm going to say this side is 9. And that angle points out here. Just think of it as like being a laser pointer. And I could say, well, there's a 7 right here. Okay, so there's our triangle that has a 30-degree angle, a 9, and a 7. But so does this triangle, 30, 9, and perhaps that 7 comes back this way. Seems reasonable that that could be 7. So this triangle is not congruent, obviously, to the big triangle. And what happened if we're doing law of sines, we'd be finding this angle first. We'd say sine of b on 9 equals sine of 30 on 7. And solve for b. All right. So let's take a look at, so we might get this angle, but maybe we should have gotten that angle in this triangle because they're both 39, 7 side-side angle triangles. How is, if I call this b prime, how are b and b prime related? Well, this inner triangle would be isosceles, making this the same as b, and this angle are supplementary. So maybe I need, if this occurs, I need b's supplement here. So remember that law of sines would give us this acute angle over here, b. But maybe it's lying to us and there's another possible triangle that includes the supplement of b. All right, let's take a look. Show you how this works. I'm going to need some space here. So A equals B equals C equals angle A equals angle B equals angle, or side A, side B, side C equals. Angle A is 76 degrees, side A is 34, side B is 21, which allows me to find sine of angle B, hopefully. Well, let's see. So that is sine of angle B on 21 equals sine of 76 on 34. Now let's solve for B. The first thing I would do, and I'm going to leave some space, you'll see why, I have to multiply 21 away. So I get 21 times sine 76 degrees divided by 34. Then to get rid of sine, I have to take sine inverse of all of that. Multiply 21, take sine inverse. So let's go back to our calculator here. And I get second sine is sine inverse 21 times sine of 76, close the parentheses, divided by 34. And I get angle B is 34.8. Now, this is a side-side angle problem. We have to be careful that there's not a second solution. Just like back here when we found angle B, we realized maybe B's over here, the supplement of B. So what I need to check is that, you don't have to write all of this out if there isn't a second one, but you sure better check. A equals B equals C equals. What I need to check is, can this supplement, let's see, I know angle A is 76. Angle B supplement, if I subtract 180, angle B supplement is 143.2. Can these two angles coexist in a triangle? No, because their sum is over 180. So there is only one solution. And it's 34.8. So only one triangle is a solution. You're going to see a case very soon where that's not where we have a second triangle. So I'm going to go 180 degrees minus A, 76 degrees, minus B, 34.8 degrees. Enter, and angle C is 69.2 degrees. So side C, my unknown, C on sine of 69.2 equals A, 34 on sine of 76 degrees. And now it's just a matter of cross multiplying. C equals, I'm going to multiply 69, sine of 69.2 across. Sine of 69.2 times 34 divided by sine of 76. And I get 32.8. So I do my quick test, my two quick tests. Biggest side 34, biggest angle 76, smallest side 21, smallest angle 34.8. And two small sides, 21 and 32, add up to be more than 34. I feel pretty comfortable. That won't catch all errors, but that should catch some errors. So we have to be alert on side-side angle problems. And now we really do, because they say use law of sines to solve. If two solutions exist, find both. So here we have, obviously not to scale, angle A 110, side A 125, side B 200. And that might be pretty suspicious looking to you right now. If not, no big deal. This is a side-side angle. I star it and just trying to remind myself, hey, I got to come back and check and see. Law of sines will lie to me. Might there be two solutions? So the first thing we're going to find, let's go A, B, C, small a, small b, small c. We've got angle A is 110. We've got side B is 200. We've got side A is 125. We can find angle B. Let's see, sine of angle B on 200 equals sine of 110 on 125. So how do we solve that for B? First, we're going to multiply 200 across, and then we have to take sine inverse of all of that. So, I thought I was hitting second quit, but I wasn't. All right, so here we go. Second, sine inverse 200 sine of 110 divided by 125 is, oh, we get a domain error. And that's what might have looked suspicious to us before. You may want to double check your work, but you may want to come back and take a look at the triangle. Angle B is opposite a side bigger than angle A is, and angle A is already 110, meaning angle B would have to be more than 110, but it can't be. Angle B has to be less than 70 for those to add up to be 180. So no solution. Your calculator will tell you it would be nice maybe if we would have recognized that prior. Okay, but this one's going to have solutions, and there's going to be a couple of them, so we want to write a little bit small here. I think I'm going to use the space up here to draw my triangle. So A, B, C. Angle A is 60, side A is 9, side B is 10. And that's not too suspicious. We know angle B has to be a little bit bigger than A. Okay, so here we go. A equals 60 degrees. B we don't know. C we don't know. Side A, whoops, didn't mean to put a parenthesis there. Side A equals 9. Side B equals 10. Side C we don't know. So this is a side-side angle problem. Maybe law of sines will lie to me and there's really two solutions. All right, let's take a look here. The only choice I have is to find angle B. So sine of B on 10 equals sine of 60 degrees on 9. So B is sine inverse of 10 multiplied across sine of 60 degrees divided by 9. So let's find that one. Quit out of here, clear there. Second sine inverse 10 sine 60. Close those parentheses before we divide by 9. And we get 74.2 for B. 74.2. All right. Now, once again, refer you back to here. We basically just found angle B over here on an angle side problem, and it was 74. But law of sines might lie to us. Maybe it was really over here, obtuse. And how do these relate? If you recall, those would be supplementary. So we have to ask ourselves, is this, can 60 and this guy supplement? Well, let's see. You wouldn't have to write all this out if we didn't know there's another triangle, but I'm going to do it just to show you the test. What we'd want to do is we'd want to see if these guys can coexist together. They can. They add up to less than 180. Well, we knew that, actually. We need to see if this guy's supplement can coexist with a 60. So let's see. 180 minus 74.2 is 105.8. But we know this angle is 60. Now, can these two live together in a triangle? They can, because their sum is under 180. So we have two sets of answers here. We have two triangles for solutions. Okay. All right, triangle 1. Angle C going to be a breeze. 180 minus 60 minus 74.2, and that is 45.8 degrees. And triangle 2, 180 minus 60 minus 105.8 is 14.2 degrees. Okay, so now let's find side C. Side C on sine of 45.8 equals, I'm going to go back up to A's, side A 9 on sine of 60, which of course is C equals, have to multiply this across, sine of 45.8 degrees times 9 divided by sine of 60 degrees. Sine of 45.8, close parentheses, times 9 divided by sine of 60, and we get 7.5. See, small angle, small side, big angle, big side. Now we're just going to repeat that for here. Here we have 14.2. That's wrong. Sorry. Here we have C on sine of 14.2 degrees equals 9 on 60. If you notice, 9 on sine of 60 degrees. And if you notice, it's pretty much the same thing. What gets changed in our equation is just what was sine of 45.8 becomes sine of 14.2 when I solve for that C. So second enter, sine of 14.2. And we get 2.5, barely, 2.5. And we take a look, biggest side, biggest angle, smallest side, smallest angle, 2.5 plus 9 is more than 10, and we have two solutions. So we need to be careful with that. All right, now, area formula. Area of an oblique triangle can be 1/2 A times B times sine of C. Let's take a look. That's A, B, C, which means if I know side A, let's say 7, and I know side B, let's say 8, and I know sine of C, oh, this is a side angle side formula. Okay, so let's see what we've got here. Maybe in the triangle given, we've got side angle side, but if we don't, we're going to have to work towards side angle side. We're going to have to find some of the missing pieces. A, B, C, certainly not to scale. 130 degrees. Side A, 92. Side C, 30. Oh, we're in luck. We've got side angle side. That's what we want for this. So area equals 1/2 times 30 times 92 times sine of angle B. And there's our area. And I'm going to leave that to you on your calculator. And number 40, let's make sure we've got what we need. Maybe you can see it without the triangle. ABC. We've got side A, 16. We got side B, 20. We got angle C, side angle side, good news. So area is 1/2 times 16 times 20 times sine of 85 degrees 45 minutes. Just to review that, I'm going to go through that one with you, the whole minutes thing. So 1/2 or 0.5 times 16 times 20 times sine of, I'm going to go 85, and now on my calculator, right here, don't know if you can see it above apps, is angle. That second apps, I'm going to put in the degree symbol, and then I'm going to put in 45 and go back to angle, second apps, and put in the minute symbol. Now, 85 degrees, 45 minutes is 3/4 of the way around the clock. That's 3/4. This could be 85.75 degrees. But if it was 42 minutes, we're going to probably want to use our calculator to do that for us. So enter, and we get 159.6 square units. Okay, from the assignment, 2018, not going to have to do 1 through 6. There's the rest of it. Should be reviewed, but we have to be really alert to the side-side angle ambiguous case possibilities. Sometimes that happens, sometimes they don't. Let me know what I can help you with.